We are now looking at video 2 of quadratic inequalities. So this problem says, same thing as before, we want to solve algebraically and then check with our graphing calculator. This time the equation, or the inequality, is 15x minus 16x squared is greater than 0. So remember that the first thing that we want to look at in a problem like this is look at where 15x minus 6x squared is equal to 0. So this one is a quadratic, but notice that there's no constant term, and so we can just factor out a common factor, which is going to be 3x. So 3x, and then here we have 5 minus 2x. Make sure you multiply it back out and double check that it works. So now that means that either 3x is equal to 0 or 5 minus 2x is equal to 0. So here if I divide both sides by 3, that means x is equal to 0, or this is negative 2x is equal to negative 5, so x is equal to 5 halves. So just like we did before, we're going to make a sign chart. So down here we'll put our x values of 0 and 5 halves, or 2.5. And then here we'll put our 3x times the quantity 5 minus 2x. And we want signs for that. So remember that when x is 0 or x is 5 halves, this product is 0. Again, if I put 0 in for x, this turns into 0, so the whole thing is 0. If I put 5 halves in for x, I get 5 minus 2 times 5 halves. So that becomes 5 minus 5. So this is 0, so the product is 0. I also want to fill in what's going on in each of these sections, right? Is it positive or is it negative? Because we're looking for where it's positive, where it's greater than 0. And so we're going to choose test values from each of those sections. And again, you can choose anything in the section. I just usually go for the easiest first one I can get. So down here, I'm going to choose negative 1. In this section right here, that's just 2.5, so I'm going to choose positive 1 here. And then in this last section right here, I'll choose 3. So remember that we're checking the sign of the 3x times the quantity 5 minus 2x. So if I substitute negative 1 in here, the 3x is going to be negative. And then if I sub negative 1 into the other one, into here, I get negative 2 times negative 1, which is a positive 2. So that's going to turn out to be positive. So this is negative. So again, I want to stress, we don't care what the exact answer is. We just want the signs. When I sub in 1, it's going to be positive times positive. So that's positive. I'll let you check that on your own. So this is positive. When we sub in 3, it's positive times negative, because we get 5 minus 6. So that's going to be negative. So this is negative. So in this one, we were looking for where the product of these is greater than 0, and we can see that that is happening in this section. Now this time, remember, or notice it says just greater than 0, and so that means that those endpoints won't be included. So our final answer as an inequality would be 0 is less than x, which is less than 5 halves, or in interval notation, it would look like this, 0 to 5 halves. Now, again, if you want to check this with your calculator, you would want to let y sub 1 equal 15x minus 6x squared. And when you graph that, you're going to get something that looks like this. And you can check those x-intercepts. This is 0, this is 5 halves. And just like before, we're looking for where that y sub 1, where the 15x squared minus 6x squared is greater than 0. So where is y sub 1 greater than 0? Where are the y values greater than 0? Well, right here. So we can again confirm the x values on that section are the x values from 0 to 5 halves.